follow along while I read the directions here. In this investigation, you will predict and observe properties and changes of several materials. Focus on making careful observations, even if you have not practiced this skill in the laboratory before. You have already developed a sense for properties of some materials and have witnessed hundreds of chemical reactions in your daily life. You will refer back to the observations you make within this investigation as you develop your understanding of chemistry ideas throughout this unit and also the year. Okay, so since we're not actually doing the lab, there's some parts of this that we're going to skip. So we're not going to have to worry about the safety precautions, but you are going to need to make predictions. And so we're going to slide down here and look at where it says record your complete data and observations. So it says quantitative data may include masses or volumes measured using tools such as a balance or graduated cylinder. Observations refer to data you can collect using your senses. So we're going to be looking at how things look, what their color is, what their texture is. We're going to be looking for bubbles. We're going to be looking for solid. We're going to be looking for something getting cloudy that wasn't cloudy before. At this point, do not try to go beyond observations to infer what is happening. For instance, suppose you add two liquids together and a solid forms. Your observation would be, when I poured liquid A into liquid B, it became cloudy. After a few minutes, I saw some white powder on the bottom of the test tube with clear, colorless liquid on top. Later, you may decide that the observation is evidence of a chemical reaction. However, your conclusion about the reaction is an inference about what happened, not an observation. So we want to make sure that as we're going through initially, we're just making observations. So now what we're going to do is we're going to scroll down to the very bottom of the document. So you have to scroll way down here. At the very end, there is a data table. And the first thing that it is going to want you to do is we want you to make some predictions. So the predictions are kind of in this section. Okay, so we're going to be basically filling in this section of our data table. So what I'm going to do is I'm going to read the directions for each of the different activities, and you are going to write your predictions, okay? And so over here on the left, you can see that we've got different stations. So we've got station A, and then we've got experiments numbers 1 and 2. So that's kind of how the directions are organized. So I'm going to read the directions, and what I want you to do is to write down what you will see, okay, or what will you hear or smell. So we want to talk about our 5 senses. What are your observations, okay? The first one is super easy. So the first one, the directions say, tear a small piece of paper into smaller pieces and place the pieces on a watch glass. Record your observations in the data table. So if we do that, if we take a piece of paper and we tear it into small pieces, what we should see are smaller pieces of paper, right? So that's our prediction. We predict that we will see smaller pieces of paper. So now, do we think that that's a physical change, a chemical change, a physical property, or a chemical property? That's a physical change. Okay, so you're going to fill that in there. Okay. All right, so investigation 2. It says place the watch glass and pieces of paper on an insulating pad. Light the pieces of paper with a lighter and allow them to burn completely. Record your observations in the data table. So what do you think the paper is going to look like after we burn it? And then decide whether you think it's a chemical change, physical change, chemical property, or physical property that's being demonstrated. Okay, so if we were actually doing this in the lab, we would have this set up at different tables. So station A would be at one table, and B would be at another table, and C, and so on. So station B, the first thing we're going to do, investigation 3, is we're going to put 1 drop of universal indicator into one of the clean, dry test tubes. Universal indicator is a solution that when added to something else, changes color according to the acidity of the solution. If I add universal indicator to an acid, it turns red. If I add universal indicator to a base, it turns blue. And if I add universal indicator to a neutral solution, it's green. Okay? So I'm going to put some universal indicator into a test tube, and then I'm going to add 10 drops of ammonia solution. What do you think you're going to see? What color do you think it will be? Green, red, or blue? And then tell me whether you think this is going to be a physical change, a chemical change, a physical property, or a chemical property. So the second part of activity 3 is we're going to do the same thing. We're going to add universal indicator, but this time we're going to add it to vinegar. Okay, so tell me what you think you're going to see. Is it going to turn red, blue, or green? And then tell me whether this is a physical change, a chemical change, physical property, or chemical property. All right, investigation 4 says, pour the contents of the test tube containing ammonia and the test tube containing vinegar together. So remember we had vinegar and universal indicator and ammonia and universal indicator. We're going to take those 2 solutions and mix them together. What color do you think it will be? And then identify as a physical or chemical property or change. So investigation 5 says use a spatula to place a single blue crystal into the mortar. And the mortar is this. Okay? And this is called the pestle, okay? So we use the mortar and pestle to crush things. So it says, use the pestle to grind the blue crystals and record your observations. So what do you think it's going to look like? And then classify it. Okay, So now, for investigation 6, it says, turn on the hot plate to a setting of high. Measure and record the mass of the crucible and the blue powder that we just crushed. Place the crucible on the hot plate and heat for 3 minutes. When the crucible is cool, measure and record the mass of the crucible and its contents. So what do you think is going to be different after we heat the blue powder? So you can talk about the color, you can talk about the mass.
Is this on number 6?
Yes, this is number 6. Okay, and then predict if it's a chemical or physical change or property. All right, so 7 is really easy. We're going to turn the hot plate on high, and then we're going to put a little tea light candle on the hot plate. We're going to put it on there for 3 to 5 minutes. What do you think it's going to look like? What will the candle look like after it's been on the hot plate for 3 to 5 minutes? What will the color look like? Will it be a solid, a liquid, or a gas? And do you think this is a chemical change, physical change, chemical property, or physical property? And then investigation 8 is really easy. We're just going to take a different tea light and we're going to light it. So it says light the wick on the second tea light with a match. Observe for 3 to 5 minutes. What will you see happen? Don't say it's good burning. We want to say, we can say that there's a flame. We can say that we think the wick is going to change color. Okay? And don't forget to classify it. Okay, investigation 9 says place a small amount of solid baking soda into a clean test tube. Add 5 drops of vinegar solution to the baking soda in the test tube. What will happen? So write down what you think will happen. And then, is it a chemical or physical change or property? Number 10 is dispense 10 drops of baking soda solution. So instead of solid baking soda, we're going to have a solution of baking soda and water, and we're going to put that into a test tube. Then we're going to add 5 drops of vinegar solution. So what do you think you will see? So we're putting a baking soda and water solution and a vinegar solution together in our test tube. Okay? And make sure you do the prediction. Chemical or physical change or property. Number 11 is dispense 10 drops of baking soda solution and add 1 drop of silver nitrate solution. What do you think you will see? And classify it. So then activity number 12 says count and use 10 post-1982 pennies, measure their mass and their volume, and then take some 1980 or pre-1982 pennies, take their mass and volume. We're going to use the mass and the volume to calculate the density. Do you think the density of pre-1982 pennies and post-1982 pennies are going to be the same, different? Do you think the post-1982 pennies are going to have a greater density than the pre-1982 pennies, or you think it's going to be the other way around? If you think there's going to be a change. And our very last demonstration that we're going to do is we're going to take some of the blue crystals from earlier on, and we're going to dissolve it in water. And then we're going to put an iron nail in that solution. What do you think is going to happen? Okay. So write that down. Include your prediction, chemical or physical change or property. So when you finish this whole red box should be filled in. You should have all of that information in your data table. Now, as we go through each of the demonstrations, you're going to record your observations on the right-hand side of the paper. So you're going to record your observations over here, and also decide if it's a physical or chemical change or property. So remember from our notes, the way we can tell that there's been a chemical change, we're going to look for those 4 macroscopic signs. We're going to look for a change in color. We're going to look for a change in temperature. We're going to look for a formation of a gas. We're going to look for the formation of a precipitate. So those are the things that we're going to look at, those clues we're going to look for to show us that a chemical change has happened. And remember, the whole reason why we have to do that is because we know that in a chemical change, atoms get rearranged, but we can't see atoms. So we have to use something else to get clues that the atoms have been rearranged, okay?